Question number 1. Liquid water can store more heat energy than an equal amount of any other naturally occurring substance because liquid water. The important thing to remember when answering this question is that specific heat of a substance shows how fast an object heats up or cools down compared to water. The larger the specific heat value of a substance, the more heat it takes to increase its temperature. The important parts of this question are liquid water and store more heat energy. These are the clues about what the correct answer is. Question number 2. How do the rates of warming and cooling of land surfaces compare to the rates of warming and cooling of ocean surfaces? So again, our important clues here are rates of warming and cooling for land surfaces compared to rates of warming and cooling to ocean surfaces. And the thing to remember here is that the larger the specific heat value of a substance, the slower the substance heats up and cools down compared to other substances. When you are looking at your specific heat chart in your reference table on page 1, remember that land is represented by the two given rocks in this chart, basalt and granite. Question number 3. The same amount of heat energy is added to equal masses of lead, iron, basalt, and water at room temperature. Assuming no phase change takes place, which substance will have the smallest change in temperature? So we have important stuff here. We have the same amount of heat energy being added to equal masses, so they're all the same, of lead, iron, basalt, and water. They're starting off at the same temperature. No phase change takes place, and it's asking which substance is going to have the smallest change in temperature. So we're looking for which substance, lead, iron, basalt, or water, will have the smallest change in temperature. The important thing to remember for this question is that the greater the specific heat value is for a substance, the slower it will take for it to undergo a temperature change. So the greater the specific heat value, the larger the number for a substance, the slower it will undergo a change, the longer it will take to change temperature. So what you need to ask yourself is, if you're going to have a small change, will it take a long time to change temperature, or will it take a short time to change temperature? Question number 4. 5-gram samples of granite, basalt, iron, and copper at room temperature are placed in a beaker of boiling water. Which sample would reach a temperature of 60 degrees first? So important stuff here. We have the same mass for each one of these samples, same mass for granite, basalt, iron, and copper. They're starting off at the same temperature. They're starting off at room temperature, and they're placed in a beaker of boiling water. And we know water boils at about 100 degrees Celsius. And it's asking which sample would reach a temperature of 60 degrees first. This is the important part. It's asking which one's going to reach 60 degrees first. That means that it is going to heat up the quickest. Remember that all of the given substances have the same mass and are at the same initial temperature. Once they are placed in the boiling water, the substance that has a lower specific heat will increase temperature the fastest. Question number 5. When the sun sets, which material would cool down the fastest, assuming they all have the same mass and initial temperature? So we're looking for which material is going to cool the fastest. Remember that something that heats up quickly also cools down quickly. So you are looking for something with a low specific heat. Question 6. Large oceans moderate the climatic temperatures of surrounding coastal land areas Because the temperature of water, ocean water, changes. So when we read this, moderates means to even out. It means that it's making it more equal. So it moderates the temperatures of surrounding coastal land areas because the temperature of ocean water changes. What you need to remember is what the specific heat of water is. If you look at your specific heat chart, you will notice that water has a high specific heat. So what does that mean about how quickly or slowly it will cool down or heat up? Compared to the climate conditions of dry inland locations, the climate conditions of locations influenced by a nearby ocean generally result in. So we are comparing land to water climates. What we need to remember is the specific heat of land, which is lower, which means that it will heat up and cool down quickly compared to water, where it will heat up and cool down slowly. So if we know land's going to heat up quickly and cool down quickly, what does that mean in the summer? If land heats up quickly in the summer, we should expect that we are going to have warm summers. And if it cools down quickly in the winter, we should expect that we have cold winters with a large temperature range. So if we're talking about ocean climates or locations near the ocean, we should expect the opposite effect because the specific heat of